Let's look at two examples where we need to use the product of the quotient rule to differentiate something that involves an exponential component to it. So we have x squared times e to the power of 6x. Let's differentiate it, and because it's a product of two separate functions, we're going to use the product rule. So u would be the first function, x squared, and v, let me do it in a different colour, v would be the e to the power of 6x. Now let's differentiate these. Du by dx would just be 2x. dv by dx, okay, well think about what we just discussed. It'll be e to the power of 6x, but then times the derivative of the power, so the chain rule in action here, and the derivative of the power is just 6, so we get 6e to the power of 6. Okay, now we need to use these in our product rule, and if you're not sure what the product rule is, get the formula book ready. Okay, so dy by dx equals, it's almost like a cross product really. You got a u, which is x squared, times the derivative of v, which is 6e to the power of 6x, plus v, which is e to the power of 6x, times derivative of u, which is 2x. So it's going like this, that times that, plus that times that. Right, now let's clean this up a little bit and see if we can factorize it or do whatever to it. We'll clean that up. 6x squared e to the power of 6x plus, what do we got here? 2x e to the power of 6x. Well, you can leave it like that if you want to. That is the derivative, but we can factor something out because we have an x and an x squared, so one of those can come out. We have a 2 and a 6, and 2 goes into both of them, so 2 can come out. Let me put a bracket in. We have an e to the power of x and e to the power of 6x, e to the power of 6x, so that can come out. So what does that leave us? Well, to get a 6 here I need a 3, and to get an x squared I need an x. So when I multiply that, I get 6x squared e to the power of 6x. And what do I need here? I just need a 1, because when I multiply that, I get, by this, I get this. So there you go. Just a nice, neatened version of it. There you go, cleaned up. 2x e to the power of 6x times bracket through x plus 1. Okay, let's do one more where we have to use the quotient. Okay, so quotient number 2 now. What do we got? We've got y equals e to the power of x plus 5 over power minus x plus 2. Okay, so right, this is a quotient, so your u is going to be the numerator and your v is going to be the denominator. Okay, so let's differentiate these. du by dx would be, now it's an addition, it doesn't make any difference, differentiate each component. E to the power of x is just e to the power of x, and then differential of a number on its own is 0, and it's just e to the power of x. Right, dv by dx, that equals, and you can check it with the chain rule if you want, minus e to the power of minus x. Okay, plus 0. Right, now let's stick these two into the quotient rule. So we have, remember the quotient rule starts with v, so v to the power minus x plus 2 times the derivative of u, which is e to the power of x, minus, what do we have, u, which is 6x squared plus 5, times the derivative of v, which is minus e to the power minus x, all divided by v squared, so that's e minus x plus 2 squared. Right, let's clean this up a little bit. Okay, so let's multiply this bracket out. Well, let's do e to the x times e to the power minus x. Well, I'm just going to write that over here as to what that is. Okay, so e to the power of x times e to the power minus x. Remember to add the powers. E to the power 0, which is just 1, so you get a 1 plus 2e to the power of x. That's that times that. Right, I'm going to sort out this minus. No, I'll tell you what, I'll put minus and then I'll do it later. Then, okay, so this times this, which would be minus 6 x squared e to the power minus x. Why have I put x squared? Hang on. That's wrong, isn't it? So, sorry, my mistake. Not 6x squared. Why did I think it was 6x squared? That's completely wrong, sorry. It's u, isn't it? It's just e to the x. My mistake. So then that's completely wrong. We'll need to rub that out. Okay, so apologies for that. So that times that is a minus 1 plus, no, not plus, minus 5 e to the power minus x, okay, divided by minus x plus 2 squared. Okay, now let's just get rid of this bracket. Minus 1 times that, minus 1 times that, so we get a 1 plus 2 e to the power of x plus 1 plus 5 e to the power minus x. I'm not going to bother expanding the double bracket on the bottom. I'm just going to leave it as it is. But we can clean up the numerator. 1 and 1 gives us a 2 plus 2 e to the power of x plus 5 e to the power minus x over e to the power of x, I forgot the square, sorry, plus 2 square. There you go. That's our dy by dx. Cleaned up. Okay, that's how you use the derivative of e to the x and so on, so forth. Is what it is. Alright, okay, in the next clips we're going to look at logarithms.